All right, this is part 2 of the Unit 2 review. We're starting with question 1 on force, mass, and acceleration. What is the net force on a 0.5 kilogram tennis ball? So remember, we have the equation Fg equals mg, and then F equals ma. And I also have the equation that I'm not going to write down yet, that really big equation that's on the back side. So we also have this equation. But let's focus on these two equations, and can we differentiate between which one we're going to use? Honestly, because g is also an acceleration, if you were to use either one of these, I'm not going to take off, as long as you write the equation down. So for force, what is the net force? That's what I'm looking for, so that's x. If we have a mass of 0.5 kilograms and an acceleration of 5 meters per second squared. Equation F equals ma, because those are the three things I have. So for x, I just write down F for x. M is going to be 0.5 and then 5. So 1/2 of 5 should be 2.5 times 5. So here's my 2.5. So here's the biggest challenge that my students are having. When they have the easy problem that's already ready to be solved, they want to do more algebra. If the x is on the left, you just multiply the two numbers. Don't do anything extra. These are the guys where you're going to see what is the acceleration, what is the mass. Now we're going to do some algebra. So the force here is 10,000 newtons. The acceleration is 4 meters per second squared. And what is the mass? This also is meters per second squared. So meters per second is meters per second squared. F equals ma is still our equation. And we're going to do 10,000 equals 4x. So simple algebra, always divide the number next to the variable to both sides. In this case, I'm going to divide 4 to both sides. I'm just going to put the colors here. divide 4, so 10,000 divided by 4 is a mass of 2,500 kilograms. So that's our answer here. Now we have a football player with a mass of 75 kilograms. If the force is 10 newtons of somebody pushing him, what is the acceleration of the football player? F equals ma. Force is 10 newtons. Mass is 75. And acceleration is what we want to find out, so that becomes x. Again, divide the number next to the variable to both sides. So 10 divided by 75 will give you an acceleration of 0.13 meters per second squared. All right, let's move on to conceptual questions. Someone is driving you to school and it's going 35 miles per hour. You decide not to wear your seatbelt. And what happens when somebody pushes on the brakes? Well, you are going to continue to move at 35 miles per hour. You continue to move at 35 miles per hour until a force, the windshield, the dashboard, acts on your body. The ground. I guess I'm going to stay with the blue. Why does this happen? It's Newton's first law. An object in motion stays in motion. How does mass affect acceleration? We talked about relationships between variables depending on where they are based on the equal sign. Mass and acceleration are on the same side of the equal sign. These have an indirect relationship. Therefore, when you increase mass will decrease acceleration. You did a whole lab on this. Our lab was all related to this question. You wrote something up for me, so please remember that. So what is the relationship between force and acceleration if those are on the opposite side of the equal? This is going to be a direct relationship. What does that mean? That if you push something with more force, it will cause an increase in acceleration. So there's going to be more acceleration. Okay. And then how does mass affect force? I don't think we usually talk about mass and force, but I guess we could in the aspect that they are on opposite sides, so they are direct relationship. If you want to move something that has more mass, you're going to need more force. So if there's more mass, it will require more force to push it. Okay, so you are moving at a constant velocity. What does that mean for the net force? Is this balanced or unbalanced? Constant velocity is when there is no net force. So constant velocity has a net force of 0. And this is going to give us balanced forces. Same for the rest. So these two are going to be the same. Constant velocity and at rest have no acceleration. And because there's no acceleration, we're going to have net force of 0 and balanced forces. So objects that are not moving have a net force of 0. And these are balanced forces. And then on the other hand, if something is accelerating, now you have a net force of some number, okay? So the net force will not be 0. And the forces are unbalanced. And then our last one, between Ryan and Scott, who will accelerate faster, assuming they provide the same force when they run. Okay, so if that's the case, then Scott is going to accelerate faster because he has less mass. So Scott has less mass and will accelerate faster. And this is all about Newton's second law. Alright, we're going to start on with a new video just because I can't have to keep them within 10 minutes. Next video.